Welcome to Lens's Streaming SQL, a great way to create real-time data-driven apps. Use it to combine events in new, creative ways as they happen. Alright, let's have a look. In this scenario, let's pretend that I'm working for that cool taxi company, Lensycab. Ah, that name. Timeless. So, Lensycab is launching a new initiative, Lensycab Green. We want to change our taxi fleet to eco-friendly electric cars. Great news, but we're still a startup. Our budget is limited. We can't upgrade all the cars in one go. Instead, we need to do it gradually. Make sure that the cars we replace each time are the ones causing the biggest impact. You know, those gas guzzlers. I'm a developer with a new green product team, and it's my mission to build something that dynamically picks our biggest gas guzzlers to replace. How do we approach this? Lensycab is a real-time business. Here, everything is data events. It turns out that our taxis are already equipped with tech and sensors. They give us live fuel consumption and trip information, including distance. So, how do I do this? Let's fire up Lenses and get a closer look at our data. I'm in the Lenses data catalog and I'm looking for trips. Good. Let's open that dataset in a new tab. Next, let's search for fuel. Found the fuel consumptions dataset. Open that one too. Back to the taxi trips. I can see that for each trip I have the distance, the date, and the car's ID. Good. In our fuel consumptions data now, I have the fuel consumed, the car's ID, and the time when the sensor made the reading. Okay, I can work with these. So, here's the plan. We are going to design a system for continuous metrics, broken down by taxi and day. From the taxis, I have trip and fuel data going to Kafka. Step 1. On the trip side, we'll create a Lenses SQL app to keep calculating daily mileage for each taxi. Step 2. On the fuel side, I'll add another SQL app to give me continuous daily fuel consumptions, again, per taxi. Step 3, aka the big join. An SQL app to combine the mileage and consumption, get the ratio, which gives us our fuel efficiency. With that in place, the rest is easy. We just pick the bottom entries and they'll be our gas guzzlers. Let's do this. Step 1, daily mileage. I'll head to the SQL Processor section and create a new one. I'll name it daily mileage. Leave one runner for now. I'm setting the auto-create to true so that my processor can auto-create the output Kafka topic. My SQL is going to have two sections. I'll use the with syntax to define the first step that will select only the fields I want from the trips data. This selection is what we call a projection. Second step, I will use the output of the previous step, sum the distance by taxi and day, and insert it into a fresh topic called daily mileage. The summing part is what we call an aggregation. You will notice I'm grouping by car ID and date here. Okay, our processor is defined. Let's start it. It's green and running. At the bottom, we can also see the logical plan that the processor is taking to do the data transformations. You can see mapping and aggregation steps here. Let's head to the topology view and see how our streaming ecosystem has changed. Here we can see our SQL processor taking data from taxi trips, summing it, and out to the daily mileage topic. Let's check the resulting data. Looks good. Step 2. Daily consumption. Here I'll follow the same pattern, two sections. First section, I'll get the date from the sensor time using built-in SQL functions. Then, sum the consumption, grouping again by the car ID and date. Nice, up and running as well. In the topology, we can see both our apps now symmetrically doing their thing. And the data also look good. Step 3. The join. Here I'm creating the fuel efficiency app. I will join the daily mileage topic with the daily consumptions topic, and I will be calculating the efficiency ratio as fuel liters per 100 kilometers. I'm joining the streams using the car ID and date for join keys. These will become also our Kafka key in the topic. I'll insert the data with a bit of renaming of our joining keys for clarity. Finally, you'll notice that I'm treating the result as a table. This makes it a stateful transformation, producing a K-table with a compacted topic because we only really care about the latest event per key. Great! It's running, and in the processor plan we can clearly see the join transformation taking place. Off to the topology to see the end result. Nice! We can see the end-to-end flow here with data joining and ending in the fuel efficiency topic. Let's check the data. Nice, we have our composite key of car ID and date and the produced efficiency ratio. And Lens SQL has also automatically created the schema for the value and key of the topic. Job done. We created 3 SQL apps and made it happen. But can we do better? Yes, we can. The twist. Instead of 3 separate apps, we can combine all these transformations into one powerful SQL app. We simply copy the parts and then turn the intermediate inserts into widths. And presto! The plan is now proper serious. And if we look at the topology, we can see how simpler our all-in-one version is, doing without the intermediate manual topics. Mission accomplished. All this thanks to Lens's Streaming SQL. Time to explore DataOps with Lenses yourself. Sign up and let us know how you find it.